Come back to my channel. If you are visiting this space for the first time, you are also highly welcome. In this lecture, I'll be looking at the histology of the uterine tube. I've put up a lecture on the gross anatomy of the uterine tube. If you've not checked up that lecture, please kindly go and do so to keep yourself updated. But for the purpose of this class, we would be focusing on the microscopic anatomy of the uterine tube. If you use this image by the side here, this is where we have the different sub-regions of the microscopic layer of the uterine tube. When you extract the uterine tube and process it into histological section, this is the kind of configuration that you would see. This region here that is harrowed in yellow is the inner mucosa layer, while this region that follows suit with it, that is harrowed here in red, is the muscularis layer. While we have the most outer covering that is harrowed here in blue as the serosa layer. We'll be looking at the details of these different sub-layers of the uterine tube in this lecture. So ride on with me. The uterine tubes are tubular extensions from the uterus. Using this image by the side, this is where we have the uterine tube here harrowed at this point. These uterine tubes are two in number. So as we have one on this side, we also have the other one on the other side. And this region that is harrowed here in blue is the uterus. We say that the uterine tubes are tubular extensions from the superior part of the body of the uterus. This is where we have the body of the uterus. And if you look at the superior angle here at this point, is where we have these tubular extensions that are referred to as the uterine tube. And if you go more laterally at this point, that is harrowed here in black, is where we have the ovaries. As we have two uterine tubes, we also have two ovaries, and we should have two ovaries because as soon as the egg is released from the ovary, they are released into the lumen of the uterine tube. It is within this uterine tube that we have the process of fertilization taking place before the fertilized egg will finally be implanted into the endometrial wall of the uterus. So you can see that these three organs are located around the same region and they are positioned close to one another because they perform similar functions as it relates to reproduction, and they need to be located closely together. And if you go through in details of the functions of the uterine tube, you see that basically they are responsible for transporting the egg that is released in the ovary into the lumen of the uterine tube. It is this same uterine tube that is responsible for transporting this egg into the specific region of the uterine tube, which is the ampulla, where fertilization will take place. And after the process of fertilization, it is still this same uterine tube that will allow for the movement of the fertilized egg and be directed into the uterus. And they are also seen to be responsible for nourishing the oocyte and also the sperm cell. And also after fertilization, they are also seen to provide nourishment for the fertilized egg, which is the zygote. So they are responsible for movement and also providing nutrients for the structures that are located within it. These functions of the uterine tube can be attributed to the histological feature of the uterine tube. We'll be unfolding this as we go through with this lecture, where we'll be describing in details how the microscopic anatomy of the uterine tube can be used to justify the functions that they perform in this regard. It is also important for us to highlight that the different sub-regions of the uterine tube are distinct. We are distinct in their sizes and also in their thickness. And this is attributed also to the histological configuration of the uterine tube. We know that specific regions of the uterine tube are known for specific functions, and they're able to perform these functions also based on their histological characteristics. So if you extract the uterine tube and you process it into histological section, this is the kind of presentation that you would see. So you see that the uterine tube is made up of three distinct layers. We have the mucosa layer. This mucosa layer is what is harrowed here in yellow. This mucosa layer is the innermost layer of the uterine tube, and this is followed by the muscularis layer. This is the muscularis layer here that is harrowed in red. This muscularis layer is the middle layer, and it is sandwiched between the innermost and also the outermost layer. While the outermost layer is the serosa layer. This serosa layer is the outer covering of the uterine tube. And this is what is harrowed here in blue. So you see that we have three distinct layers of the uterine tube going through the histological section of this organ. We would be dwelling or driving into each of these layers and also explaining the details that they present. We'll also be attributing their features to the functions that they perform in their specific regions. So let's first drive into the mucosa layer. The mucosa layer, we say that it is the deepest layer. This is the layer that is harrowed here in yellow. The mucosa layer is thrown into folds. So you see pronounced folds within the mucosa layer of the uterine tube. These folds are referred to as placi, and it is seen to be pronounced more in the ampulla region. The folds are also further seen to increase downwards towards the infundibulum that is directed towards the fimbriae of the uterine tube. So towards the fimbriae of the uterine tube, you see that there is increase in the projection of the folds that the mucosa layer exhibits. While if you go more medially towards the uterus, you see that the folds tend to decrease. So it tends to decrease towards the intramural part of the uterine tube. So you see that these folds will decrease towards that region, while it will be seen to increase towards the fimbriae region. That is the infundibulum of the uterine tube. So if you drive deep also into the mucosa layer, this is where we have the infoldings created by the mucosa layer. We say that the mucosa layer is not seen in a straight patterned configuration. They are seen to be thrown into folds. And you see that these folds are projected into the lumen of the uterine tube. So this is where we have the lumen of the uterine tube here, also arrowed in yellow. This lumen is the space that is located within the inner compartment of the uterine tube. But a number of folds are seen to be driven into the lumen of the uterine tube. And this is why you have this kind of configuration. So driving into what the mucosal lining is made up of, structurally, the mucosal layer of the uterine tube is made up of a simple columnar epithelium that is located on the lamina propria. So you have the lamina propria underneath it, while you have simple columnar epithelium that is overlying on it. If you try to use this upper image here, this is where we have the epithelium lining at this superior region, while inferiorly you see that the epithelium lining is laid onto the lamina propria. And this lamina propria is a loose type of connective tissue. And this is what is seen here in this image. So you see that this configuration are then thrown into folds, and they are seen to penetrate furthermore into the lumen of the uterine tube. So going further on the epithelium lining, this epithelium are of three types within the mucosal layer of the uterine tube. So we have the ciliated simple columnar epithelium. This ciliated simple columnar epithelium, just as the name implies, it means that they have cilia on their free surfaces. Remember that this is the configuration of a simple columnar epithelium. So if you go up onto the free surface here, you see that you have ciliary projections on the apical surface to facilitate wave-like movements. These cilia are seen to wave forward and backward, and as they do this, they are helping to move the substances that are located within the lumen of the uterine tube along that course. So they help contribute to movement. And this is why you see this projection here on the free surface. And where you see more of this type of epithelium is in the infundibulum. You also see more also in the ampulla region. We know that in the infundibulum, which is the terminal region of the uterine tube, is where we have the released egg. The released egg from the ovary is released into the lumen of the uterine tube. The first region that it gets to is the infundibulum, because this is the terminal part of the uterine tube. And more so, this is the region that is positioned close to the ovary. So the egg is first released into the infundibulum. And from the infundibulum, it needs to be taken to the ampulla region where fertilization will take place. So it is this egg-like projection that will help to facilitate the movement of the egg that is released in this region into the ampulla region where fertilization will take place. And also after the process of fertilization, the fertilized egg also will need to be moved into the lumen of the uterus where it will be implanted. So it also needs to also exert some form of movement. And this is why you have more of the ciliated type of columnar epithelium in these two regions, because these are the regions where movements are needed to be exerted. So it is important that we're able to highlight this. Then the second type of simple columnar epithelium that we have are the non-ciliated type of epithelium. These are referred to as the PEG cells. They are secretory in nature. So what they do is that they help to secrete substances that are needed to nourish the egg, the sperm, and also the fertilized egg. They are also seen to contribute to the process of capacitation. We know that capacitation is a process that needs to occur before fertilization will be allowed. So it also helps to facilitate this process. The non-ciliated simple columnar epithelium, which are secretory in nature, are not seen with cilia on their free surfaces. This is the non-ciliated simple columnar epithelium here, highlighted in red. So you see it at this region here. And if you look at the free surfaces, cilia are not attached to the free surfaces. But what they do is basically secretory function. And this is why it is helping to contribute to the process of producing substances that are needed to protect the structures that are located within it. And if you look deep into the configuration of this non-ciliated columnar epithelium, you see that they are taller. And the reason for this is basically to create more space for secretory vesicles, because they are secretory in nature and they need more space to accommodate the secretory vesicles. And this is why you see that they appear to be taller than the ciliated type of epithelium. And this is what is seen here to be carried in red. And this epithelium are seen more in the ampulla region and also the isthmus. And we can justify why they are seen more in the ampulla region and also the isthmus. The ampulla region is the region where fertilization would take place. And this fertilized egg needs to be nourished. And this is why you see more of the secretory type of simple columnar epithelium in this region. Also, we say that this secretion that is produced by this epithelium also aid the process of capacitation. And we know that capacitation needs to occur before fertilization would occur. And this process, of course, also occur in the ampulla region. So that is why you see that more of the secretory simple columnar type of epithelium are located more in the ampulla region, and also the isthmus, which is the region that is next to it. So it is important that we're able to justify where we have more of these types of cells. The last type of cell that we have is the intercalated cell. The intercalated cells are inactive secretory cells. So they are more like the non-ciliated secretory type of epithelium, but they are inactive. And if you see this cell, they are also sandwiched within the mucosa layer of the uterine tube, and they appear to be shorter. So if you try to compare the configuration with the non-ciliated secretory type of epithelium, which is say that it is longer, you see that the intercalated cells are non-secretory, and hence they appear to be shorter because they are not producing anything. So they do not need space to accommodate any secretory vesicle. So these are the different types of cells that you have within the mucosa layer of the uterine tube. And we also try to describe the specific regions where we have more of these cells, in also helping to relate to the functions that they exhibit. So going to the second layer is the muscularis layer, and it is the middle layer that is located between the inner mucosa layer and the outer serosa layer. This muscularis layer is made up of two sub-regions. We have the inner thicker circular layer. If you go back to this image, this region that is highlighted in red is the muscularis layer, and this is the inner thicker circular layer. It runs a circular configuration, and it is located more in the inner region. And this is why it is so referred to as the inner circular layer. And it is also thicker in terms of its configuration. What it does basically, because it runs in a circular pattern, it helps to control the process of expansion. Remember, the uterine tube is a tubular structure. So it's helping to control its expansion and also its relaxation because of its circular orientation. But when you see more deposits of the inner thicker circular layer is around the intramural region and also the isthmus. We know that these two regions are closer to the uterine tube. After the process of fertilization in the ampulla, the egg that is fertilized, we say, needs to be implanted in the uterus. So it needs to run through the isthmus and also the intramural layer. So you need more of the contraction and relaxation around this point for it to propel or move the fertilized egg into the uterine tube. And this is why you have more deposit of this specific layer of the muscularis layer. The second layer that we have within the muscularis layer is the outer thinner longitudinal layer. And this is what is seen to be harrowed here in this image. It is located in the outer part of the inner thicker circular layer. It is thinner in terms of its configuration, and it is seen to run a longitudinal course. Remember, the inner thicker circular layer is seen to run a circular orientation, and this is why it is helping to expand and also relax the lumen of the uterine tube. While the outer thinner longitudinal layer is seen to run through a longitudinal course. And in this regard, it is helping to control the elongation of the uterine tube. You can see that the two different sublayers of the muscularis layer are destined or programmed for different types of movement. While one is responsible for controlling expansion and relaxation, the other one is responsible for controlling movement along the vertical axis. So if you try to combine expansion and also elongation, you have a wave-like peristaltic movement. So you have a peristaltic movement that is exerted by the muscularis layer due to the pattern by which the fibers of the muscles run. So the integration of the expansion and also elongation is going to be producing a peristaltic movement. And this peristaltic movement will help in aiding the movement of the gametes along the lumen of the uterine tube. It is also important for us to know that the infundibulum and the ampulla are seen to have a wider lumen. And this wider lumen can also be attributed to deposits of the muscularis layer, which means that the muscularis layer is not thick around this region. And this is why you have that the lumen appears to be wider, in creating more space for structures that are located within it. Remember, we said that fertilization occurs in the ampulla region. Of course, the process of fertilization also needs some form of space for this process to occur. So it's helping to create more space. You see that the deposit of the muscularis layer here is not as thick as what you see in the other region. And also for the infundibulum, which is the terminal region, the egg that is released by the ovary also needs to move. So in trying to create space for this, it's also helping to reduce the thickness of the muscularis layer around this region. So going to the third layer, which is the outer serosa layer. This is the outer covering of the uterine tube. And if you use this image here, this is the region arrowed here in blue. This serosa layer is basically made up of the visceral peritoneum. We know that the uterine tube is covered with visceral peritoneal layer, and this is what is seen in the outer serosa. And this region is basically made up of mesothelium. The mesothelium are simple squamous epithelial cells embedded within the connective tissue. And this is the kind of configuration here that you see on this outer region. You also see blood and also lymphatic vessels. This structure that is harrowed there at this point is the outer serosa layer. And within it, you have simple squamous epithelial cells within a connective tissue. You also have deposits of blood and also lymphatic vessels. And this is what is harrowed here in blue at this region. These are the three layers of the uterine tube. And we've tried to describe each of these three layers in details, also relating the features that they present using the microscopic anatomy to relate with the function that they exert. Thanks for watching this video. Let's continue to stay glued to this channel.